Hi everyone. So, kind of to piggyback on our last video, in this video we're going to do the opposite process where instead of given a graph of f of x and we want to graph f prime of x, the derivative, instead we're going to do something where we're given a graph of the derivative and we want to graph what the actual function looks like. Now, I'll say right off the bat, this is usually harder to do. It's sometimes harder to go backwards than it is to go forwards, but I'll show you how you'll do that with a couple example functions in this video. So, this Desmos function is very similar to the one we had before. We still have this slider for xi that we can move between our initial point of x equals -4 and our final point of x equals 4. And so right here, this blue line, again, is the graph of the derivative. And the red line is going to be the graph of the function. So remember what a derivative is. A derivative is a function that gives us the slope of the line tangent to the curve at any given point. So what this is saying right down here, when we're at a value of x equals -4, this is saying that the slope of our function is negative, and it's actually fairly steep negative, okay? So again, I've highlighted this black dotted line, which shows the slope of the line tangent to our curve, which will be represented by the red line traced out by the red dot. So if I move this slider around, you're going to see this, okay? So we're going to end up, the red line is going to trace out what the function is, and the blue line is going to trace what the derivative is. So let's go back a little bit. All right, remember that the dotted black line is the slope of our function, or the slope of the red line. So when our blue line, again, is way down here, it's saying we have a very big negative slope. And as you can see, looking at the black line, it's a very big negative slope, okay? So what is the blue line telling us what's going to happen to that slope? Well, as we move up along the blue line, what's that telling us? Now that we're right here, that's saying, well, hey, our slope is still negative, but it's not quite as negative, okay? This initial value right here was more negative than this new value right here. So as you can see, our black dotted line is getting a little bit shallower. So as we move this blue line up through here, when we eventually get to this point, what is that telling us? Well, that's telling us the slope of our line is 0, all right? And more specifically, when we're before that point, let's say over here, that's saying the slope of our line is negative. When we get above that 0 crossing, it's saying the slope of our line is positive. So if I erase all this stuff right here, and we go ahead and keep moving, that's exactly what's going to happen. Our slope gets less and less, our slope gets less and less and less negative until right here it becomes about 0, and then the slope starts going positive, so the graph moves up. Okay? So again, we're doing the same kind of analysis steps we did before. We're just doing it in reverse. So now we're looking at the graph of f prime of x and saying, okay, that's telling us what the slope of our actual function looks like. So let's draw an actual function that has a slope that mimics the graph of the derivative. So one important thing to point out right here is that when you're going from graphing a function based on the derivative, one thing this doesn't tell us is basically where that red line is going to occur along the y-axis. So it could be just as legitimate for that red line to look something like this, or it could look something like this, okay? Because the slopes of all three of these lines, the two I just drew and the red one that we created in Desmos, the slopes are always the same at every x value. So that's one kind of ambiguity we get when we go from a derivative to an actual function, is we don't actually know what we would call maybe like the y-intercept, okay? That y-intercept can vary, but as long as the actual function has this general shape, all three of these curves I just drew will have the exact same plot for the derivative, which is the blue line right there. All right, so let's just do one more just as practice. This time, when we go to this next function, again, try to draw it out yourself or kind of visualize what it would be on your own before you take the video forward. So let's go down here. Let's change our function to be a cubic function. All right, so let's do something like that. So now that we have all this, we have, again, the blue line is the graph of our derivative, so f prime of x is this blue line right here. So based on that graph of the derivative, try on your own to figure out the general shape of what the function would look like. Pause the video. All right, so if you've tried to do that, let's see what that function will look like, okay? If I go, that's not very fast. All right. Okay, so if I go to animate this, why are you doing that? Okay, here we go. If we go to animate this, we'll see the actual function would look something like this. It's a cubic, okay? So remember what this is telling us, okay? It's saying as we're over here, let's actually zoom out a bit so we can see the whole function. So as we're over here, remember, if the derivative is a big positive number, that's saying we have a big positive slope. Look at this black dotted line right here. Doesn't that look like a big positive slope? So therefore, if we have a big positive slope, that means the red line or the function is going to be moving up. It's got a positive slope. Its rate of change is positive. If we keep moving it, that slope, as it's moving down, as the blue dot is moving down, what that's telling us is that the slope is getting less steep and less steep and less steep. So what's happening is our red line, though it's still climbing up, it's climbing up at a slower rate, okay? So if we keep animating that a little bit more forward, we're going to see that eventually the blue line gets around here to 0, and I'll zoom in so we can see this specific point. But once that blue line gets closer and closer to 0, again, that's saying our slope of our actual curve is getting shallower and shallower and shallower. Look at what's happening to that black dotted line. That slope is getting shallower and shallower until we get to a part where the slope is 0, which is going to be like a little hump. Then here, it's saying the slope is negative. Look at the black dotted line. The black dotted line has a negative slope right now. So if we keep going, we're still a negative slope. It's its steepest point negative here. And now the blue line starts moving back up towards the x-axis, meaning our slope is getting shallower. That's exactly what's happening with the red line. And then as we keep moving forward, we eventually develop this shape. So again, maybe rewind this video a couple times and see this if this is still confusing, or come tomorrow in class with questions and we can go over it a little bit more. But generally, I've found that students find it harder to graph a function from a derivative than to graph a derivative from a function.